Okay, so this next video is for the demo coders that are developing or will develop software and demos for this new hardware I'm developing, which is a smartwatch, a game console, two game consoles actually, and all the stuff is, it's all about micro miniaturization, so everything is small as possible. So anyway, this demo right here, what I've been experimenting with are various kinds of infrared emitters and detectors and capacitive sensing to do 3D gesture recognition in midair. So this is challenging for a number of reasons. If you've ever done these kind of algorithms, I don't need to tell you why, but there's a lot of digital signal processing involved and a lot of problems that have to be taken into consideration to get this to actually work. So, one thing that's surprising is no one that I've seen has an iPad or an iPhone or anything like that with built-in gesture recognition in the air using the camera or any other sensor. So that just tells you it's not an easy problem to solve. So anyway, so the idea is, on touch screens we touch the screen and that's all fine and dandy, but I'd rather just make gestures in the air with my fingers or whatever. And of course, this is not rocket science. It's doable, but very few small devices have these kind of features. And why they'd be nice is, say you're in the kitchen, you're cooking, you've got your recipe on your iPad or whatever, and you got your hands all dirty, you don't want to touch the screen, so it'd be nice if you could just wave your hand and go to the next page or go to the next page or do a circle or whatever. So that's kind of what I'm working on here. So anyway, so the gesture recognition hardware is right here, and it's fairly simple. 3 infrared emitters and detectors, ambient detectors, and infrared ambient detectors. I take all of that data, I collect it in real time, and then put it through a number of low-pass filters, automatic gain control filters, and then convolve the data with various search filters so that I can find gesture events, sort them temporally, and then compute what kind of gesture is occurring. Is it a swipe to the right, a swipe to the left, a swipe up, a swipe down, and so on and so forth. So I've got this all working, and I've designed a printed circuit board, a large-scale one, to put the gesture recognition hardware on, and that's right here. You can see this little circuit board around here. So I'm not using that right now. I just got that back from manufacturing, so I'll be moving this to here next. But I just wanted to show the demo coders this. They've been asking about it so they can see it. So that's what we're going to do right now. So what I'm going to do is I'm going to run this first program. So let me see here if I can hit the enter key. Alright, so what we're seeing here on the screen is the 3 different channels. And what I'm going to do here is I'm just going to rotate this a little bit. Actually not, I'm going to leave it like this so you can see the whole system going. So what we've got is 3 different channels. Now, the interesting thing about this problem when you try to solve it is the data coming in from the infrared detectors is many orders of magnitude or many scales of magnitude. It's goes from 10 to 100 to 1,000, so it's basically to 10,000, 4 orders of magnitude. So what that means is you could have signals hiding in a very small range or a very large range. So you have to have an automatic gain control system that understands this so that I can differentiate noise from actual gestures. So that alone is not the simplest thing to get working properly. And of course you can see this is very ghetto right now. It's just on a little solderless breadboard. It's very messy and makes the signals hard to read and so forth. But even with this, I've got it really working nice, so once I move everything to the PCB, it'll be nice and clean. So what I want to do now is I want to show you what happens as I move my hand over here. So you're going to see there were 3 different events there, and 3 different events, and you can kind of see their temporal dislocation as I hit each one of these sensors. The red, the green, and the blue represent sensor 1, sensor 2, and sensor 3 respectively. So as I move my hand quickly, you can see that in either direction, the events all happen almost simultaneously, but there's a slight difference in the amount of time. We're talking about milliseconds here. So we have to differentiate that, and then we have to also do automatic gain control, because if my hand goes up at an angle or down at an angle, I might get a signal on one sensor from 0 to 1,000. On another sensor, I might get that signal from 0 to 10,000. So we have to basically get all this data together. So anyway, so let's swipe and let's see. It finds the events. So those are swiping events, and it's what that white line represents the center, and it's putting a pattern matching template and trying to find these events. And now we're scanning them both temporally and in amplitude space, so that if I go slow, it doesn't detect it, because that's not the rate that we want this at. So we want a specific rate. So that's a swipe. That's a swipe. that's a swipe, that's a swipe. So we wanted to be able to tell what's going on here. Now, this will be interesting. I'll do 2 swipes, and then as you can see, as I do the 2 swipes, it automatically gain controls the second event, because that's the new event and that's the one of importance. So that's it. So the whole thing is working and scanning everything and giving me the data. So now we have to take all that data, collect that, and then we run it through gesture recognition algorithms and to get the result and figure out, are you swiping right, swiping left, swiping up, swiping down. So now we're going to take a look at that. So I'm going to stop this real quick and then add that in. Okay, so what we can see here is a little graphic here, iBird Explorer, and so one of my friends who puts together an iPhone app called iBird wanted to see what the images would look like on this tiny small screen to see you know, how they look. So I kind of took some random images off internet and kind of mocked up what it would look like. So these images look nice for a demo, so we're gonna use them. So the whole idea here is just to show you what this might be like. So we have the hardware over here, and then we've got the image here. So I'm just going to back away so you can see the whole thing. So I do a swipe and see if my fingers, that's not a swipe because my fingers now. And so you've got to do a proper swipe and the proper speed. So there's a proper swipe, there's a proper swipe, there's a proper swipe, there's a proper swipe, oops, proper swipe. You've also got to have it parallel because that's the way I'm reading it. And then the cool thing is you can do this with your fingers, and again you've got to do a proper swipe or it's not going to detect it. Alright, and then you know, once you get the hang of this, you can sit here and do this all day long, and it's very cool because you don't have to touch anything. So anyway, so that's, you know, that's what this is all about. And now of course I'll have the hardware so I can just do it right over the screen image itself. Obviously that's what you want. Now the other thing that's cool is the altitude here. When I'm doing these swipes, I can do it at a low altitude or I can do it at a higher altitude. Let me get a proper swipe, and then that's a low altitude, again proper swipe, low altitude. So again, it's doing automatic gain control, and doesn't matter what the altitude of my hand is, which we call the target. And even though the reflectance and the amount of infrared radiation reflected back is different, we have that automatic gain control, so altitude is irrelevant. So as long as we can get some of the signal out and then we can pull it out of the noise, we can read it. So anyway, so it's very cool. And then so just, you know, imagine you're sitting there on your screen, and just with your little, you know, couple little fingers, you can just like make these little gestures. And then of course you could also have gesturing up and whatnot. I've just got them tied to right and left right now. But you know, you can go through these things, and very cool. So, and then you can do more complex gestures. Once you have this hardware, then you can gesture in 3D space, do circles, zigzags, whatever. And as long as you do them in the right speed and so forth, then it would pick that up. So that's it. So 3D gesture recognition in space, floating above, and next I'll integrate it into the hardware and move on to the next piece of technology that's going to end up in these smartwatches. Bye.